Now we'll start section 2. We open the section 2 example notebook from our GitHub. You click GitHub and type BAOSCNZ, hit enter. We can find out the section 2 example notebook and you click it. It will load the example notebook and you click copy to drive, and this notebook will be saved in your Google Drive and you can modify as you want. Now it is creating a copy to your Google Drive. Now you get a copy of example notebook that is about kangaroo detection. And now we'll start this part. So first, we congratulate on you to finish the previous practice and have understanding of Python basics, machine learning, and image classification. And we'll welcome you to this section that is about object detection with mask RCN. This is a quick and good start and intro to using the predefined model to detect objects. And the code is referred from the mask RCN GitHub and the blog. Some more examples can be found from there, and the environment is built up in this notebook and the code can be directly running. So if you want to learn new things, it's better to find out the root knowledge. If you want to learn mask RCN, this GitHub project is one root learning resources we cannot avoid. So you can click it to see. This is the mask RCN original project, and you can click the shapes. There is an example code to tell us how to use the mask RCN. We click the train shapes, and then it will load the mask RCN train on shapes dataset Colab notebook. So this notebook shows how to train mask RCN on your own dataset. We use the dataset from the GitHub, and this is the link, and we modify it to suit our situation. The dataset is not big, so it requires less training time, but you still need a GPU. Here is the table of content. First, we'll need to set up the environment, and then the rest of the process is the same within section 1. So you will load the images dataset and prepare the data and configurations and train custom model and evaluate, and finally run inference on tested dataset or new images. So first we'll set up our environment. We will need to install mask RCN repository from the GitHub. This is the mask RCN GitHub original project, and some necessary packages. We need to make sure the packages we are using is the correct version. Let's see here if we use TensorFlow. Here is the version we like to use, and the Keras, here is the correct version we like to use. You always need to make sure you use the correct version, otherwise you will have errors when you run this code. So we can click it, start, and it will start to running this code and install those packages. And this code is to clone mask RCN repo and install the mask RCN packages. We can click the start and let it start to run. And then you click start for this one. This one is the change the root directory of project, import mask RCN, import coco config. So all of this code is adapted from our root original mask RCN project. It's the same with this one. Okay, and then let's go back. after you finish set up the environment, after we finish running the code in setup environment part, and then you will see that in files you have a mask rcnn folder. So actually this is the mask rcnn project you get from the mask rcn GitHub, and then we will load images dataset, and we will clone the project from our GitHub, and the kangaroo dataset is included inside this GitHub project. You click it, and after it finish, you can also refresh the files. You will see that another folder is created in here. This is our amoeba detection GitHub project. And then you can click this code file. This copy the dataset from GitHub folder to content just in here. So we will see we copied the kangaroo dataset training and the kangaroo dataset test from our GitHub, and we refresh the files. You will see these two folders. These two contains the kangaroo dataset. If we open it, the training dataset, so we can actually visualize the image. So you will see there's a cute kangaroo image shows up in here, right? And you will also have the anodes folder. The anodes folder contains the bounding box information, and it saves in the .xml files, and those files is corresponding to the images. So if you open up one .xml files, actually these annotation files is corresponding to the images in our right. So you will find out it contains two objects, the first one and the second one. This is the kangaroo because you will see that there is two kangaroos in the right image, and in the object it contains the name of the class, and it also contains the bounding box information. So it used the 4 points for the rectangular box to represent this bounding box. To better understanding our later code, we'll need to know what does the .xml look, and to extract our informations from these files. Okay, let's start the data preparation and configuration. You will see at first these tons of code. Actually, this code is adapted from the mask RCN GitHub, this train shapes example. So we will find out the code is in here. So you adapted from that code. And first, you'll define a class kangaroo dataset and define a function load dataset. In here, you will add classes, and because we have one class, it is a kangaroo, and you have another class, is a default class, is a background, and then you will tell this function where the image and annotations file. If you give it this dataset value is the training dataset, so actually it will find out the locations of these folders, and then you loop those files. In those files, you can skip some bad images, and based on the image numbers in here, so it can split the training and validation dataset. So which means this number can be changed. It's based on how many training data you want to give it to him and how many validation dataset you want to give it to it. Okay, and this is the load dataset function, just help us load our images and annotation files. And then you will extract bounding boxes from annotation files. It's like from the .xml XML files from here. So you have already what does this file looks like. So you will see that you find out that files and find out that bounding box and also the 4 points for the rectangular box and draw it. So here is what it does to extract the bounding box, and then return the boxes and also width and height. Also, you can load the masks for an image, and for the object detection, you do not need load mask for an image. But it's also good for you to have this mask in here. And then you prepare train set by telling the functions of the training dataset folder and prepare it the same way for the validation dataset. And you print the length of the dataset. So you will find out the training dataset contains images of 141. For the validation dataset, we have 22 images. And then we will define config files. So if you are first to touch these configuration files, you probably don't know what does it mean. So it means that configuration files allows us to separate the code from the parameters of machine learning pipeline to help produce repeatable outcomes. So you will use the parameters in the configuration files to run the training. And so we will change some parameters in here. Number of the class is 2. It's just the background plus one kangaroo. And you change the steps per epoch and the detection and MS threshold. And you can use the code config.display. It will display all of the parameters in the configuration files. You can read it in here and change it. It will affect our training performance. Okay, for training the model, first we'll run TensorBoard. TensorBoard is a tool to provide the measurements and visualizations during the training. So more information about TensorBoard can be found in this link. And then you will get a TensorBoard CB. So you just give this TensorBoard CB to the custom callbacks when you do the model.train, and it will run the TensorBoard during the training so that you can visualize your training process. And then you start to use this code to run the training. So in this code is kind of easy. We don't see any mask RCN structures. So the structures is described in the original paper, and also I cover it in my PPT. If you want to look at the details of mask RCN structure, you can go to the mask RCNN folder in here, and you find out the mask RCNN and the model.py. You just click it. So we can take a look at this model.py. So this shows the model structures. So you will see that some familiar definitions in the model.py, like a region proposal network, I cover it in my slides. And also you will find out some loss functions and so on. Many familiar definitions in this model.py. So this tells us the mask RCN structure, and but we do not need to write it again. So just use model.train, give it training dataset, validation dataset, and also give it some parameters like linear rate, and give it 5 epochs. It will start to run. For the layers, there's 2 options. I provided this information here, so you can train only the heads by pass layers equals heads. So here we are freezing all backbone layers and training only the randomly initialized layer. And another one is fine-tune all layers. It will take a longer time than the first option. So you just pass layers equals all, and you will fine-tune all layers. So I have already clicked the start button. You will see that the it start the epoch 1. It will take a little bit of time. So after it finish, we'll continue to talk about the evaluate model and run the inference. Another thing I need to mention is you can just ignore these warning informations, because you will see it start to training. It's a good sign. After you click this start button, it will start the training process. And this process will take a very long time. If you think this is too long, you can change this epoch number to 1. So for this example, if you set it to 1, the results is not too bad. And then after the training process finished, so you will see a folder like this, and it saves all 5 different mask RCN models that have been trained with on the Kangaroo dataset. And you also see this My Logs folder. This will save your TensorBoard visualization. And then you start evaluate the trained model. You define the prediction config and define a function evaluate model to calculate the MAP. We have already talked about MAP in our slides. It's a way to evaluate a model. And then you will find out the model path, and using model.loadWeights from that model path. Here is the way we like to use in here. Another way is to set a specific path. It's just change weights path to run this code. So we like to use this one to find out the model path. And then you will load the train dataset, validation dataset, and the test dataset, and run the evaluate model function that we defined previously to evaluate the model on training dataset, validation dataset, and a test dataset. And here is the results we can get: the train MAP, validation MAP, and a test MAP. So it's not bad in our case. And for visualization of the TensorBoard, you can comment out this code. It will show the TensorBoard file. Finally, we will run the inference. Here is the code for the inference. The very important code is model.detect. So by running this code, the model will detect the new images. The previous code is just to pre-process the images. And then you will draw the box and confidence within that image. Finally, you find out the directory for that image and loop the image inside that directory, and let the model detect the kangaroo. And here is the output. You will see that in the test dataset, it give the bounding box for the kangaroo and also the confidence about it. And this is the code to let us save the prediction test dataset to our local computer.